My name is Crystal Sheldon. I am the Director for Java and Education at Oracle. This webinar is called All About Enum, and it's a continuation of a webinar that I conducted a month ago where we started to look at different ways that we can represent data in a program, and we developed out a deck of cards in that. And there were some things that we could have leveraged in that program from enum that we didn't, and we're going to today. So I want to do a recap for people who were not here a month ago, or maybe you didn't watch the recording. There is a recording, so if you're interested in rewatching that, you can. It's posted on our webpage at learn.java. But let me just recap for you. We didn't get very far, so no worries. We created an enum for suit for a deck of cards, and we created an enum for the face of the card, ace 2 through 10, jack, queen, king. And we created a record for a card that has a suit and a face of a card. It also had a card value and whether the card was a face card or not a face card. So I had a Boolean for that. We also created a class for a deck of cards. And when we created that deck of cards, we used loops and switch expressions to create card objects and then assign them to an array list. A little bit of a recap about what an enum is. It is a type of class. So it is a class. It represents a group of named constants, and it is used when we have a finite set of possible values. So you could use a class, but because we know what values a suit has or the face of the card has, we can use an enum instead of having the universe be all the strings you can possibly think of. So here's an example. We have enum suit, hearts, spades, clubs, diamonds, and we included that in our program to create our deck of cards. Enums can include methods and fields, and that is part of what we're going to look at today, as well as constructors, and it's going to make this program really seamless and very readable. Okay, so the general look of an enum, we do enum, the name of the enum, and then the constants that the enum can be assigned to. They're all going to be in uppercase, just like we do constants in other areas of our programs. So we've got a keyword enum, the name of the enum, and then the list of constants. To create an enum, we're going to use the name of the class. This is just like creating any other object. The name of the object equals, but in this case, because we know what those constants are, it's the name of the class dot the constant that we want the value to be. And this is what our program looked like. We had an enum for suit. Again, like I said, the options are in all uppercase here, and then a face of card enum. All right, and then we went ahead and we created the deck of cards, and we did this in a really not so straightforward way. So I kind of used a little like, well, we've got 4 suits, so I'll iterate 4 times, one for each suit, and I'll create a card for each of those, and we have 13 different either number cards or face cards. So we'll do a loop for 13 times. And I use some switch expressions here to, based on where we were in the iteration of suit value, determine what suit we were on. And in the iteration of face, we determined what face card we were on. And then we had to also do switch cases for card value and its face value. And then we added them to our array list, which was deck. And we got all our cards out, but that is a lot and not very readable. It's a lot to kind of process for creating this deck of cards. So, and it causes problems where we play a game where there's 5 suits. So if we have to add another suit, say stars, how does that affect our program? So we'd have to change the enum, which is not a big deal, but then we have to go in and manually change how we're constructing the deck as well. We have to now loop 5 times. We need to add stars here, and you can kind of see how this would kind of compound. So there has to be a better way, and there is, and that is to iterate over the enum values. There's a way to do that. So we had to be really creative, like I said, to assign the current suit and the face card to the appropriate enum values. We had to be really creative here with these for loops, iterating the right number of times. There's got to be a better way. So there is a method that you can use with enums called values. And what it does is it returns a list that contains those constants in the order that they're listed when you declare the enum. So you're actually getting a list, and if you're getting a list, that means you can use an enhanced for loop to iterate over those values, and now we can iterate over the values of the enum. So here's the general format. It's a for each loop, so you've got the name of the enum class is going to be here, a variable for each value in the list, the name of the class, and then dot values for the method that you can call that will return that list to you. And then there you go. You've got all that you need. So how is that going to affect our program? Well, we're going to take these loops where we were iterating 1 to 4 and 1 to 13, and now we're going to iterate over those values. So for suit value, colon, suit values, and then for face of card, face of card dot values. So those are going to give us those values. And now we're just going to pair those things together when we create cards. So essentially this whole big block on the left with these two switch cases is now these two nested for loop statements where we're iterating over a list of values instead of trying to come up with what those values are going to be. A lot more readable. The whole code fits on the screen now for this constructor of deck. We still have to deal with card value in isFace. It made card value a little bit more complicated because now I didn't have numbers to do my switch cases over. I had to switch over all of my face card values. So you can see that on the right hand side. So that makes that a little bit more cumbersome. isFace is about the same amount of effort and work here. I kind of switched my orders for my case so I didn't have to type everything out, and I did the case where it was a face as true first and I defaulted the rest. So I kind of did a little shortcut there. Okay, so what does that mean? Now if we add stars to our enum, we don't have to change anything in deck. It'll work automatically because it's going to iterate over the suit, and in the suit it's going to have the 5 different values to it, so it will go one more time. But I want to look at this section here with this switch case for card value and isFace because I think we can do better here as well. Card value is determined based on the face of the card, as you can see here. And isFace is also determined by the face of the card. So these are all connected. The card value and whether or not it's a face card is really determined by what face it is. So they really shouldn't be treated separate like this. It's really part of this face value or face of card object value. So we can add instance variables to face of card and a constructor as well as other methods so that we can store the card value and whether or not it's a face card or not right with the enum. So let's see what that's going to look like. So this is the general format for when you want to have constructors and methods in the enum. You're going to do your enum, name of your enum, just like you normally would. But now for each one of your constants, you're going to have values for instance variables. So however many of those that you have, obviously separated by commas there, you're going to have those listed out. The last one, you're going to have a semicolon at the end. Then you'll have your instance variables. So whatever type those are, your instance variables. And then this is your constructor for your enum. So your name of your enum and then your parameter list there, and you're setting the var1 value to val1. Let's see what that looks like in this example. So here is our face of card. We wanted it not just to be ace, but we wanted to know what the value was. In this case, I made ace through 9 worth whatever their actual numbers were. And then 10, jack, queen, king were worth 10 points. And then if they're not a jack, queen, king, they're not a face card, so they're set to false. And jack, queen, king are face cards, so those are true. So each constant has a value for the card value and the isFace card value, and they're just put in parentheses there. Note that there's a semicolon at the end. It's a little different. And then we have our instance variables here, card value and isFace card. And our constructor takes those two values. And I'm just using this dot card value, and and this dot is face card to access my instance variables, and then assigning those to the parameters there. So what does that mean? It means that I don't need to have those switch expressions to get the suit value and whether or not it's a face card. All I need is the suit value and the face, because face includes the card value and the is card. So it really condensed everything down to this nested for loop statements here. So we went from this in the last iteration on the left to this value on the right here, where we're just adding the new card. Our enum can have additional methods. So maybe you want to have some accessor methods here, like get card value and is face. You can have those in there as well. Maybe this is something where you're doing some calculations. You can have all sorts of methods in here with your enum, because an enum is a type of class. If you want to learn more about enums, we have a few pages on learn.java. So we have this introduction to using enum that you can go to. I have a practice set for that as well. I have an iterating over enum, which is what we just learned in the first part of today's activity, and a practice set for that as well. And I just added a tutorial on constructors and methods using enum, and those can all be found in the learn section and the practice section of learn.java. So if you want to recap, feel free to look there. Thank you all for being here, and have a great rest of your week.